Okay, let's do a solution to number 4. So a gambler bets $1 and either wins the dollar or loses a dollar with equal probability. If she starts with $50 and plays either until she wins her target amount or goes broke, the questions are, what's the probability that she'll get her target amount? And also, what's the average number of bets that we expect it to take? So what makes this problem different than the other problems is it requires both patterns. We need the pattern for the probability of something and also the pattern for the average result of something. But the experiment that we're running in both cases is the same. It's having the gambler repeatedly bet and win and lose until they either go bust or win their target amount. So if we were to write a separate method for each of the kinds of results that we were trying to get, the code wouldn't be dry because the experiment, the method that runs the experiment would need to return different things depending on what we were trying to calculate. And so we'd actually need 2 different methods, but the methods would have a lot of overlapping code because they both need to model the same process. So one solution to this problem is to have the experiment method return more than one thing. So let's start in the middle there because that's the kind of heart of this. So I'm not going to start with the pattern for probability or average value. Instead, I'm going to start with the experiment method. So run gambling session. That's maybe not the best name in the world, but I'm working on it. So what does this method need as an input? It needs the starting amount of money and it needs the target amount of money. So in the example there, it was $50 to start and $250 was the target. And what it's going to return is something that we're going to ask in just a second. So this is starting money and this is target money. And what we want to do is we want to keep looping as long as their current money is between those two. So I'm going to set current money to be equal to starting money. And then I'll say while current money is larger than 0, and also current money is less than target money. So as long as we haven't hit either one of those, let's go ahead and see if we win or lose. So I'll say math.random. So if math.random is greater than 0.5, that means we have a 50% chance of that being true. So if it's true, we'll say we win. Otherwise, we'll say we lose. Okay, so what do we want to remember about this? I guess we have to remember how many times we go through the loop, because that's the same as the number of bets. So I'll set num bets to be 0. And then out here, I'll say num bets plus plus. Okay, so now we've gotten to the point where we have to decide what we want to return. If we were calculating the probability of her winning, then we'd want to return whether or not she actually won. So something like this. You could say, if the current amount of money equals the target money, then you'd return true, otherwise you'd return false. And this is actually one of those examples where you don't even need the if. You could just return if the current money equals the target money. Because if this is true, we would return true because the event that we want to find the probability for has happened. The event being she won rather than lost. But if we wanted to instead calculate the average number of bets, we'd want to return num bets. Okay, so what are we going to do? Let me show you my less favorite approach first. So my less favorite approach is let's make an int array called results that has length 2. And the first element is going to save whether or not they won, and the second element is going to be how many bets it took. Because I can't have multiple data types in the same array, I can't have whether or not they won be true or false. So I'll use 0 to be false and 1 to mean true. So I could do something like this. If current money equals target money, then we'll say results element 0 gets 1, because I'm using 1 to mean that they actually won. Otherwise, results element 0 will equal 0, meaning they didn't win. So now I'll set results element 1 to be equal to num bets. So I've taken the two things that I want to save, which is whether or not they won and the number of bets, and I've saved both those pieces of information into results, and then I can return results, which means that up here, my data type for the return type, needs to be an int array. And then back up here, I could save it into results. Let's go ahead and put this in the context of calculating the things we want to calculate now. So let's go I equals 0 to max trials, which we haven't defined yet. Here's this. Let's define max trials. Let's put this in its own method, actually. Yeah, so find. No, let's not yet. So let's define max trials. Sure, to be 10,000. All right, so for the probability, we need a counter. So num successes is going to be my counter for how many times the gambling session was successful. And average bets sum is going to be the sum for the average number of bets. And actually, I'm going to make this one a double. Let's make them both doubles. All right, so I only care. All right, so let's do this. So first, for calculating the probability, I want to know, did she actually win? And that's only true if results element 0 equals 1. Because element 0 was where we recorded whether or not she won, and 1 is the value we were using to represent winning. So really there I'm just saying, did she win? And if the answer is yes, then we'll add to number of successes. I don't actually care about the average number of bets unless she won, because the question was how many bets did it take her to get to the win. So I'm actually only going to add that here equals results 1, because that's how many bets it took. And so then at the very end of it, I can display probability of winning is going to be num successes divided by max trials. And then if I want to print average bets, I do not actually want to do average bet sum divided by max trials, because the problem is we didn't add into the average bet sum every single trial. We only added into the average bet sum whenever she was successful. So actually I would want to divide this by num successes. And that was sort of like my clever way of testing whether you were just going to try and follow the patterns without thinking about them, or whether you were going to think, what am I trying to find the probability, or what am I trying to find the average of, and how do you actually calculate that? Okay, so let's go ahead and run this, and then I'll show you, then we'll modify it slightly, and I'll show you what my preferred approach is. Oh, this is a problem elsewhere. Oh, okay, hold on. All right, so here we go, we're running it. So I actually don't know if these are right or not, but I'm getting probability of winning is like not quite 20%, and the average number of bets is about 20,000 bets. That seems high, but not necessarily. All right, so let me show you how to modify this. I don't like this int array because this is a data structure we kind of invented for ourselves, and you have to remember this awkward code about what does element 1 represent, what does element 0 represent, and what does element 1 represent, and there's like using 1 to mean true. So there's a lot of us inventing our own ad hoc system for representing things. And it would be difficult for someone else to come in and read this and know what we were talking about. So a better approach would be something like this. The two things we want to return are whether or not she won and the number of bets. So you could make an object called result, and inside result have variables for the two things that we want to take away from the method, whether or not she won and num bets. And now you can actually make them the appropriate data types for what you want them to be. I didn't make a constructor and I didn't make getters and setters because this is intended to just be what's called a data transfer object. It's just a container for other variables. So it's not supposed to have any logic in it. It's not supposed to do anything fancy. So now let's rewrite this to use the new object. So here, rather than returning an int array, I'm going to return a result object. And here, instead of building an int array, I'm going to make a result object called output, not results, called output, new result. And now, ordinarily you'd use like a setter method, like set one to something. But because our variables are public, we can just access them directly like this. So I'm setting the one variable that is inside the result object. And I'm going to set it to be either true or false. So if you don't know about something called the ternary operator, what you would do is you'd say if the current money equals the target money, then let's set it to be true. Otherwise, let's set it to be false. Java actually has a shortcut for doing this. I'm going to show you what it is right now. Output.one equals, and then I have a test that I want to run if current equals target. And then I put a question mark, and then I put two things. This is what I want to evaluate if the test rate here is true, and this is what I want to evaluate if the test is false. So if the test is, oh, this is silly me. I just want to do this. We don't even need the ternary operator. I just want to take the result of this evaluation and save it directly into one. All right, so what now? Output.numbets equals numbets. So I made this object that's just a container for my output variables, and now I saved all of the things from my gambling session into those output variables, and now I can return my output object. And then back here, instead of an int array, we would have a result object. And now instead of this, I could say if results.one, then I'll do this, and then here I'd say results.numbets. So that reads a little bit more nicely. And you'll see that it'll give us a comparable result. Yep, about the same.